Hi guys, I hope you've had a good fall break. Today's video will be on multiplying mixed numbers, but before we get into that, I want to do a little review. You don't need to write anything down for this, but it's been 2 weeks since we've talked about these things, so I want to go over them. The first thing is simplifying fractions. We looked at this on Tuesday and Wednesday 2 weeks ago. It was the week before fall break. So simplifying fractions, I'm sure you remember, just means that we take our fraction and we simplify it till it's as small as we can get it. And to do that, there's a few different ways, but the best way is to find the least common divisor, which we represent with LCD for least common divisor, and that's the same thing as our GCF, our greatest common factor. Okay, so if we are given the fraction 8 over 12, and we want to simplify this, you might already be able to see that a 4 is going to go into both of those. But let's say you couldn't see that right off, or maybe these were really big numbers and you didn't know. One way we can do that is to find the greatest common factor. So to do that, what we do is we take each of these numbers and we find its prime factorization. So 8 divides into 2 and 4. 4 factors into 2 and 2. So for my 8, I get a 2 times a 2 times a 2 for my prime factorization. For my 12, I get 2 and 6. 6 gives me 2 and 3. So then I get a 2, and a 3 for my factors of 12. So when I come over here to my Venn diagram, for my 8, I have a 2 times a 2 times a 2. For my 12, I have a 2 times a 2 times a 3 right there. And I'm going to look and see what they have in common. I can tell that already that they've both got 2 2's right there. So those go right here in the middle. And 2 times 2 is 4. So I can write it that way as well. If I do that, I'm going to cross that out so I don't get confused. Okay, I don't care about what's left over because I'm not finding the least common multiple. I'm finding the greatest common factor. So my 4 comes out, and my least common divisor, or my greatest common factor, is a 4. So now I know a factor that both an 8 and 12 have in common, and it's the biggest factor they have in common. I can use that to simplify my fraction, and I'm going to do that. To do that, I'm going to take my 8 and I'm going to divide it by 4, and I've also got to divide my 12 by 4. Okay, it's important that these numbers are the exact same, because when I do that, it's really like I'm dividing my whole fraction by a 1, because 4 over 4 is 1. If that's confusing, don't worry too much about it, just know that those have to be the same. Okay, when I do 8 divided by 4, it gives me a 2. When I do 12 divided by 4, it gives me a 3. So when my fraction's all the way simplified, I'm left with 2 over 3. And I know that this is simplified all the way because 2 is prime and 3 is prime. That's one way. I can also see that 2 and 3 are one number apart. And I know that 2 and 3 can't get any smaller, so that's my simplified fraction. The other thing I want to review quick is multiplying fractions. So that was our next video. We talked about that on Wednesday and Thursday, 2 weeks ago now. So let's look at a couple examples of this. Remember, when we're multiplying fractions, the important thing is that I multiply straight across on the top and straight across on the bottom. We called that pow-pow. Okay, but there's a trick that I can do, a shortcut if you will, that makes it a little bit easier to multiply. So I could multiply this and then simplify, but first, to make things easier, I can do what we call cross-simplifying. So I'm going to go ahead and rewrite this because I kind of made a mess with my arrows. Okay, to multiply this, I want to cross-reduce first, or cross-simplify. I always say cross-multiply, and that's wrong. We're just cross-simplifying. Okay, looking at my first diagonal right here, do I see that there's something that can go into both 2 and 4? Yes, a 2 goes into both of those. So when I divide 2 by 2, I'm left with a 1. When I divide 4 by 2, I'm left with a 2. Okay, then that diagonal's finished, and I can look at my other cross, my 3 and my 3. A 3 goes into both of those, so when I divide each of those by 3, I'm left with a 1 in their place. Now I'm left with 1 over 1 and 1 over 2 when I multiply straight across, pow-pow. I get 1 times 1 on top, which gives me a 1, 1 times 2 on the bottom, which gives me 2, and I'm left with a simplified fraction. That's what cross-simplifying does, is it puts things in its smallest pieces, so we'll have a simplified fraction at the end. and that fraction is 1/2. Okay, let's try another example. Okay, this one, my numbers are a little bit bigger. It would be kind of messy to do 15 times 20. I could do it, it's possible, but it'd be kind of yucky to do that and then have to simplify after. So this is one where I really want to do that cross-simplifying first. Okay, if I look at this diagonal, I can see already that 5 goes into 20. So when I divide 5 by 5, I get a 1. When I divide 20 by 5, I'm left with 4 in its place. And that's as small as those can go, so now I'm going to look at this diagonal. 12 doesn't go into 15, but do they have a common factor? They do. It's going to be a 3. If I divide 12 by 3, I'm left with a 4 in its place. If I divide 15 by 3, I'm left with a 5 in its place. So now I've got a 1, a 4, a 5, and a 4 left in each of those places. On top, then, if I do my pow-pow, I have a 1 times a 4, which gives me 4 on top. I have a 5 times a 4, which gives me 20 on the bottom. Okay, looking at that, is that as simplified as it can go? No. This is one where we can see right here, this fraction could have simplified before we multiplied. So I can actually simplify this even further. So my cross-simplifying helped me get it pretty far. But this one has one more step. I can see that 4 goes into both of these. So if I divide the top by 4 and the bottom by 4, 4 divided by 4 gives me a 1. 20 divided by 4 gives me a 5, and my final answer for this one would be 1/5. That one was kind of complicated. It had lots of steps and 2 times that we simplified, but we can see how it worked and we were able to do that, and we got 1/5 at the end. So we always want to double check and make sure that things are as simplified as they can go. Usually they'll work out more like this one up here where it's already simplified, but there are times when they're not, so it's always good to check. Okay, that's it for our little review. Now let's talk about the new stuff. So today we want to multiply mixed numbers. So let's talk about our vocabulary first. So first, right here in the middle, we have the definition for mixed numbers. So make sure you write this down. It says a mixed number is a whole number and a fraction together. So we can see an example of that right here, and most of us are familiar with mixed numbers. So 4 and 1/3 is a mixed number. That means that I have 4 wholes and then 1 piece left over. So if this was a chocolate bar and it had 3 pieces, that's how it could break up, then it would mean I had 4 whole chocolate bars, which would be 12 pieces of chocolate, right? And then 1 more piece. So it's like my friend ate 2 pieces of that chocolate bar and only left me 1. But it's okay because I still had 4 other chocolate bars. Okay, so I have 4 and 1/3 pieces. Another definition we're going to need to know for this assignment is improper fraction. So an improper fraction is where it's all in a fraction, but the number on top is bigger than or equal to the number on the bottom. And then we also say that the numerator is greater than the denominator. So an example of this would be like if I had 8/3, or any time where the number on top is bigger than the one on the bottom. And my improper fraction would be 4 and 1/3. I'll write in a couple examples for you. Okay, the last definition you're going to need to know, and most of this is just review, hopefully you've heard all of these before. The last word we want to do is product. So a product is what we call the answer to a multiplication problem. So the product of 2 times 3 is 6. 6 is the answer. It's the product of these two numbers times together. Okay, so hopefully you were able to write those down. If not, pause the video, get your vocabulary words written down, and then we're going to start looking at this. Okay, so these are our steps for today. So today we're multiplying these mixed numbers. So the very first thing that we want to do is we want to convert the mixed number to an improper, go ahead and write that right here, improper fraction. So let's go ahead and look at how this works. You've probably done this in 4th and 5th grade, but it's always good to review. So let's look at our example over here. And as you can see, there's a couple arrows drawn around here. So what Mrs. Ledbetter likes to do is she likes to call this going around the world. And I will call it that as well. So to convert to an improper fraction, I have to turn my number out in front into a fraction and then add it to what was right here. So I kind of mentioned this when I was telling you the definition of mixed number. Let's see what it looks like. So to do this, I start by timesing the denominator by this number out in front. Because if I've got 4 chocolate bars, I want to find out how many pieces I have. So I'm going to go 3 times 4. So I'm going to put a little times right here so we know what we did, which gave me 3 times 4 is 12. Then I've got to add it to how many pieces I had left. So 12 plus 1, so now I'm adding right here, gives me 13. So I've got 13 on top and 3 on the bottom. We could have also written that as I have 12 thirds. 4 is the same as 12 thirds plus 1/3. Remember, if the denominators are the same, I can add straight across and I get 12 plus 1 is 13 over 3. And I still have 13 thirds right there. Okay, so 13 thirds is what 4 1/3 is, written as an improper fraction. That's the first step. So if we go over to this example, let's start by doing that part. So I'm going to start with my denominator and times it by my number out in front. So I'm going to do 2 times 1 is 2. Plus another 1 is 3. So I've got 3 and my denominator stays the same. So I've got 3 halves. I've got a times right here. I'm going to do the same thing over here. 3 times 2 is 6. Plus 2 is 8. And I'm still over 3. So I have 3 halves times 8 thirds. Okay, that's the first step. Hopefully you've seen this before. If not, hopefully you'll get some good practice with it in this video. If you have questions on this, make sure you ask me because I'm happy to go over it with you. Okay, so that was the first step, is we've got to convert it into an improper fraction. From here, it's the same as multiplying fractions, just like we did before. So this next one right here is to cross simplify, like we just saw. So over here, I'm going to cross simplify. I'm going to do my big cross in the middle. 3 and 3 can reduce. If I divide both of those by 3, I'm left with a 1 and a 1. 2 and 8 can simplify. If I divide both by 2, I'm left with a 1 down here. 8 divided by 2 is 4. Okay, then I'm going to multiply straight across. So again, I have my pow. So I'm going straight across. 1 times 4 is 4. 1 times 1 is 1. And remember, anything over 1 is just itself. So this is really just a 4. And I'm done. It's that simple. So we would check to see if ours is simplified. And like right here, like I said right here, 4 over 1 can simplify to just a 4. So check that your answer is simplified. And then remember, anything over itself equals 1. Okay, that's another thing to remember. We talked about that, I think it was over here on this page right here. Anything over itself is equal to a 1. Okay, those are the few things you're going to need to know for this. So let's go now through a few more examples. This one up here was kind of easy. Let's try a few more. So all we're doing is we're multiplying these mixed numbers together. We saw this on that recipe activity, so I probably should have saved that for today's lesson. But now we know how this is going to work. So first things first, I want to convert this to an improper fraction. So remember, I've got to times this one out in front by the denominator, so I'm going to go 5 times 1 is 5, plus what's on top is a 1, so 5 plus 1 is 6. Leave it over the denominator, and I've got 6/5. Over here, same thing. 3 times 1 is 3, plus 2 gives me 5, and I leave what's on the bottom there. Okay, that was step 1. We converted to an improper fraction. Now we want to see if we can cross simplify, so I'm going to draw my cross. 6 and 3 can reduce. Those can both be divided by 3. When I do that, I'm left with a 1 and a 2. 5 and 5 can both cross reduce. When I do that, divide both of those by 5, I'm left with a 1 and a 1. Now I'm going to multiply straight across. So when we do that, we'll get a 2 on top. 2 times 1 is 2. 1 times 1 is 1. So we're left with 2 over 1. And last thing we want to do is simplify that. 2 over 1 gives me just a 2. Going back to our candy bar example, if it says that one piece makes a whole, but I've got 2 pieces, that means then I've got 2 wholes, right? So that's how I can write that as just a 2. Or you can just remember that anything over 1 is just going to be itself. That's fine too. Okay, Let's look at number 2. And here they're using the X to represent our times. Over here they use the little star. Down here they use parentheses. It all means the same thing. We're going to be multiplying on all of these. Okay, so first things first, we got to convert that to an improper fraction. So I'm going to go 4 times 2 is 8. 8 plus 3 is 11. So I've got 11 over 4, because 4 was my denominator. That stays the same. And then over here I'm going to do 12 times 1 is 12, plus 1 is 13, so I've got 13 on top and 12 on the bottom. Okay, then I want to try cross-simplifying. Okay, do 11 and 12 have any common factors? No. I know that 11 is prime, so it can't get any smaller, and it doesn't go into 12. So I can't simplify anything there. What about my 4 and my 13? 4 has factors, but not any that it shares with 13. 13's prime, so it can't break down either. So I can't simplify at all, but that's okay. I can just go ahead and I can multiply straight across. Sometimes that happens. Okay, 11 times 13, that's a little bit big, so I can write it up here. 11, 13, and I'm going to times those two together. We've hopefully seen this before. If not, you're going to learn it right now. Okay. To times these, I'm going to start with my 3. I'm going to go 3 times this one right here, which gives me 3 times 1 is 3. 3 times 1 gives me another 3. So I get 3 times that 11 is 33. Now I've got to do my 1 times my 1, but first I've got to write my placeholder 0 right there. Now I've got 1 times 1 is 1. 1 times this other 1 is another 1. And then I add these together. So 3 plus 0 is 3. 3 plus 1 is 4. 1 comes down as a 1. So 11 times 13 equals 143. That's going on top. Now I've still got to multiply straight across the bottom. If you remember your times tables, 4 times 12 is 48. And because all of those were prime and I couldn't simplify any further, that's in its simplest form. And it's okay to leave this as an improper fraction. You could convert it to a mixed number if you wanted, but I'm perfectly fine with you leaving it as 143 over 48. When you get into 7th grade and 8th grade and into high school, you're going to use improper fractions a lot. I know we tried to avoid them in elementary school, but now it's okay if we use these a lot. They're going to make math a lot easier. Okay, there are times that mixed numbers are nice, and we'll see those. Like if you're writing a recipe, it wouldn't make a whole lot of sense to say that you needed 3/2 cups of something. You would just say that you needed 1.5 cups because that's easier to measure. But if it's just a math problem on a page, an improper fraction's perfectly fine. Okay, let's look at these last 2 examples and then I'll let you go. Okay, so first things first, we're converting to an improper fraction. 9 times 5 is 45, plus the 5 on top gives me 50 over 9. It stays on the bottom. Okay, 7 over 10. I don't need to do anything with that. It's not a mixed number, it's just a fraction, so it just gets to stay the same. 7 over 10. Okay. Cross-simplifying. Can 7 and 9 simplify at all? No. I can see that 7 is prime. It doesn't share any factors with 9, so that diagonal's done. Okay, looking at my 50 and my 10, do those share something? They do. They both can be divided by 10, right? So I divide that by 10, I'm left with a 1. 50 divided by 10 is 5. And when I multiply straight across, I get 5 times 7 is 35, pow. 9 times 1 is 9, pow. And that would be my final answer. Again, I'm just going to leave that as an improper fraction. Okay, a lot of you might look at this and be like, 35, well, that can divide by 3. But if we remember, the factors of 35 are just a 5 and a 7, and that doesn't share any factors with my 9, so that one's done. Okay, last one. Remember, these parentheses just mean times, so I can rewrite it anyway. We'll see that in just a second. First, let's convert this one to an improper fraction. I'm going to do my 3 times my 4, which gave me 12. 12 plus 2 gives me 14. And I leave my 3 on the bottom, so I've got 14 thirds. I'm going to write my times with a dot, because that's how I like to write it. And then my 3/14, I don't have to rewrite that at all. It's just going to come straight down. Okay, on this one again, I'm going to cross simplify. This one works out nicely. 3 and 3 can both reduce, right? Divide both of those by 3, I'm left with a 1. 14 and 14, those both reduce as well, and I'm left with a 1 and a 1. I have a 1, a 1, a 1, and a 1. So when I multiply, I'm going to get 1 times 1 is 1, 1 times 1 is 1, 1 over 1, it's just 1. Kind of out there between the boxes, sorry. It's just a 1. Another way we could look at this if we wanted to, 14 thirds times 3 fourteenths. Remember in, I think it was the multiplying fractions video, we talked about the commutative property of multiplication. That says it doesn't matter what order we multiply things in. Because we're multiplying and we're going straight across the top and the bottom, we could even rewrite these. We could rewrite these as 3 over 3 and 14 over 14. Okay, and let's be careful when we do that. 14 thirds is not the same as 3 over 3, but because I'm timesing these two fractions and timesing these two will still give me the same answer. Okay, I can see that those reduce to a 1, those reduce to a 1, and so I'd have 1 times 1, which is 1. Either way you do it will give you the right answer, and it's a 1. And this is going to be important to know because we're going to talk about that in a couple lessons later this week. Okay, now it's your turn to do the pause and try. Remember that all of these times symbols, they all mean the same thing, to multiply. Follow these steps up here, and I will see you in class. Bye, have a good night.